Right now, as you're watching this, billions of particles are passing through your body. Not air molecules, not dust. Something far stranger. Something that doesn't interact with your atoms at all. It passes through you like you're not even there. Like a ghost moving through walls. And without this invisible substance, you wouldn't exist. Neither would Earth. Neither would the Sun. Neither would any galaxy in the universe. 3 days ago, scientists released a photograph of this ghost, the most detailed image ever captured of something we cannot see. A paper published in Nature Astronomy contains what might be the most important map in the history of cosmology. Using the James Webb Space Telescope, an international team spent 255 hours staring at a single patch of sky. They identified nearly 800,000 galaxies. And then they did something that should be impossible. They photographed the invisible scaffolding holding all of it together. Dark matter, the thing that makes up 27% of the universe, the thing that has never been directly detected, the thing that passes through your body billions of times per second without you ever noticing. We just saw it in stunning detail. And what the map reveals is forcing scientists to rethink everything about how the universe was built. Here's the problem with dark matter. It doesn't emit light, it doesn't reflect light, it doesn't absorb light, it doesn't block light, it doesn't interact with ordinary matter in any way we can measure directly. The only thing it does is bend space, and that's exactly how they photographed it. When light from a distant galaxy travels toward Earth, it has to pass through whatever's between us and that galaxy. If there's a massive concentration of dark matter along the way, that mass warps the fabric of space-time itself. Einstein predicted this over a century ago. Light follows the curvature. The galaxy's image gets distorted, stretched, smeared, like looking through a warped bathroom window. One galaxy getting slightly distorted doesn't tell you much. Could be the galaxy's natural shape. Could be noise in the detector. But when you measure the distortion of 800,000 galaxies, patterns emerge. The distortions aren't random. They align. They point toward invisible concentrations of mass. Mass that bends light but produces none of its own. This technique is called gravitational lensing, and the James Webb Space Telescope just revolutionized it. The same patch of sky was mapped in 2007 using the Hubble Space Telescope. Same region, same technique, some of the same scientists. Nearly 20 years later, they came back with Webb. And when Dr. Diana Scognamiglio presented the new map next to the old one at a collaboration meeting, something unexpected happened. The room started clapping. Not polite applause, recognition. They could see dark matter in ways that were impossible before. The new map is twice as sharp as anything Hubble produced. It contains 10 times more galaxies than ground-based telescopes can detect. Where the old map showed blurry concentrations of invisible mass, the new one reveals fine details, filaments, threads, the actual cosmic web that connects everything. Think about what that means. The universe isn't just scattered with galaxies randomly. There's a structure, a skeleton, made entirely of something we cannot see. And galaxies aren't floating through empty space. They're clinging to this invisible framework like water droplets on a spiderweb. Dr. Richard Massey from Durham University put it this way, quote, "Wherever we see a big cluster of thousands of galaxies, we also see an equally massive amount of dark matter in the same place. And when we see a thin string of regular matter connecting two of those clusters, we see a string of dark matter as well," end quote. They're everywhere together, dark matter and ordinary matter. They didn't just end up in the same places by accident, they grew up together. And here's the part that should make you uncomfortable. Dark matter got there first. In the earliest moments after the Big Bang, the universe was a hot, dense soup of particles and radiation. Everything was spread almost evenly. Almost. There were tiny fluctuations, microscopic variations in density, and dark matter, because it doesn't interact with light, started clumping together while ordinary matter was still being pushed around by radiation pressure. Dark matter built the scaffolding first. It collapsed into dense regions connected by filaments, and then slowly ordinary matter fell into those gravitational wells. That's where the first stars formed. That's where galaxies assembled, not randomly, in the places dark matter had already prepared for them. Dr. Jason Rhodes from NASA's Jet Propulsion Laboratory made this explicit. Quote, "This map provides stronger evidence that without dark matter, we might not have the elements in our galaxy that allowed life to appear." End quote. The chain of causation goes like this. Dark matter clumped. Its gravity pulled in ordinary matter. Dense regions formed where stars could ignite. Those stars fused hydrogen into heavier elements. Carbon, oxygen, iron. Those elements got scattered when the stars exploded. Some of that scattered material condensed into planets. One of those planets was Earth. You are made of atoms that only exist because dark matter organized the universe first. That's not philosophy. That's the physics we can now see in this map. But let's talk about what we still can't see. Because this map, as revolutionary as it is, doesn't answer the most fundamental question. What is dark matter actually made of? We've narrowed it down. It's not ordinary matter that's just dark. We know how much ordinary matter exists from measurements of the cosmic microwave background. There's not enough of it, even if we include all the black holes and rogue planets and cold gas clouds we can imagine. The extra gravity has to come from something else. The leading candidates are particles we've never detected. WIMPs, weakly interacting massive particles, or axions, extremely light particles that barely interact with anything, or maybe primordial black holes, tiny black holes formed in the first moments after the Big Bang. Decades of experiments have searched for these particles. Underground detectors, particle colliders, space telescopes, nothing. We've found nothing. And yet this map shows us dark matter is absolutely real. We can see its effects. We can trace its distribution. We can watch how it shapes the universe. We just can't figure out what it's made of. This is the strange situation modern physics finds itself in. We have overwhelming evidence for something we cannot explain. Every observation confirms dark matter exists. Galaxy rotation curves, gravitational lensing, the cosmic microwave background, the large-scale structure of the universe, all of it points to the same conclusion. There's 5 times more invisible matter than visible matter, and we have no idea what it is. Some physicists think we're asking the wrong question entirely. Maybe dark matter isn't a particle at all. Maybe our theory of gravity is incomplete. A modification called MOND, modified Newtonian dynamics, can explain some observations without invoking invisible matter. It suggests gravity behaves differently at extremely low accelerations. The math works for individual galaxies, but it struggles with galaxy clusters, and it really struggles with observations like the Bullet cluster, where 2 clusters collided and the dark matter passed right through while the hot gas got stuck in the middle. Maps like the one just released make MOND harder to defend. Now the limitations. This map covers an area of sky about 2.5 times the size of the full moon. That's it. A tiny patch. The universe is enormous, and we've mapped dark matter in detail across an area you could cover with your thumb held at arm's length. The map is also 2-dimensional. It shows where dark matter is concentrated as seen from Earth, but structures at different distances get projected onto the same flat image. The team is working on 3-dimensional reconstructions, but that's future work, and the technique only reveals large-scale structures, galaxy clusters, cosmic filaments. It can't resolve the dark matter halo around an individual galaxy. The distortions are too subtle. You need statistics across thousands of galaxies to pull the signal out of the noise. But here's what's coming. The European Space Agency's Euclid telescope is already in orbit, designed specifically to map dark matter across huge swaths of sky. NASA's Nancy Grace Roman Space Telescope launches in about a year. It will survey an area 4,400 times larger than this Webb map. The Vera C. Rubin Observatory in Chile will image the entire visible southern sky repeatedly, tracking how dark matter distribution changes over cosmic time. We're entering an era where dark matter mapping becomes routine. This Webb observation is the proof of concept, the demonstration that we can photograph the invisible in stunning detail. What comes next will be vast. Dr. Scognamiglio said something that stuck with me. Quote, "I hope that 20 years from now, my student will be able to make an even better map." End quote. 20 years ago, she was the student, working on that original Hubble map. Now she's leading the team that just shattered what Hubble could do. Science is generational. Each advance builds on the last. And sometimes you get to come back to the same patch of sky with better tools and see something that makes a room full of scientists stand up and applaud. Here's what keeps me up at night thinking about this. Everything we've ever seen, every star, every galaxy, every planet, every atom in your body, all of it together makes up 5% of the universe. 5%. Dark matter is 27%. Dark energy, something even weirder, is 68%. We are made of the rare stuff. The exotic material in the universe isn't invisible mass or mysterious energy. It's us. Ordinary matter is the anomaly. And yet that 5% is all we've ever known. All of human history. All of science. All of art and love and war and everything that matters to us. It all happened within this tiny fraction of what exists. We just photographed part of the other 95%. Not directly, never directly, but through its effects on light, through the way it bends space, through the shapes of 800,000 distorted galaxies, we trace the outline of the invisible architecture that made everything visible possible. Billions of particles are passing through you right now. They don't notice you're there. They'll keep going, through the Earth, through the sun, into the void, forever. They've been doing this since before the Earth existed, before the sun ignited, before the Milky Way formed from collapsing gas falling into a well of invisible gravity. You exist because of something you will never touch, something that doesn't interact with light or matter or anything you can measure directly, something we've hunted for decades with the most sensitive detectors ever built and never caught. But we can see where it is now, in higher resolution than ever before. The ghost has a shape. What else is hiding in plain sight?